Hello everyone. In this lesson we are going to explore real-world linear functions by using the rate of change and the initial value. So right now we're just going to get into some questions for the do now, just finding the slope and y-intercept of the following linear functions. Remember, number one, if it's in y equals mx plus b format, you could just go ahead and get the m, which is the number before the x, so that is 1, and the 12 is the y-intercept. Remember, it has to be in that format, y equals mx plus b, to do that, and it is, so there's nothing else to do. But this one is not. It's not in y equals mx plus b, so you have to go ahead and solve for y. To solve for y, all you're going to do is add 5 on both sides, and you cancel them out there, and y equals 3/4 x plus 5. And you notice that you have y equals mx plus b format, and the slope is the number that is before the x. It's called the coefficient, and the other number, which is the constant, is the b, your y-intercept. Right, and that is a 5. For the third one, it is the most difficult question. You have to solve for y, but right now it is not in y equals mx plus b format. It is 3y minus 4x equals 3. We're going to add 4x on both sides. And once we add 4x on both sides, remember, using inverse operations to do that, this cancels, and then you have 3y equals, and I'm going to put the 4x first, plus 3. And then you're going to divide by 3 on both sides. And you see this fraction here, we're going to keep this fraction. This is 4/3. And we're going to keep that, so the slope is 4/3. And then the 3 divided by 3 is 1. So the y-intercept is 1. The question below, which of the linear functions above has the steepest slope? Remember, the steepest slope is the line with that has the slope that is furthest away from 0. This is 1. So that's 1 away from 0. 3/4 is 0.75 away from 0. And 4 divided by 3, if you ever want to see what that is as a decimal, 4 divided by 3 equals 1.333, which is the furthest away from 0. So line 3 has the steepest slope. So into the launch, and we are going to basically talk about a real-world situation that we have a phone card, and the phone card cost is graphed for you. It's graphed with a y-axis and an x-axis. This is the y-axis right here. This is the x-axis. So the y-axis shows dollars. So we're going to put dollars down here. And the x-axis shows minutes. So we're going to talk about finding the m, the rate of change, right? The slope. So this is called slope, and it's also called rate of change. Whenever you hear those words, rate of change, I want you to think about slope. And that is not how you spell change. Okay. So we're just going to do the rise over run like we normally would do. I'm going to go ahead and choose this point here and this point here. Remember, you could choose any 2 points. When the points are closer together, it's better because you don't have to reduce the fraction at all. And also it might, picking points that are further apart might lead to maybe counting wrong or something like that, making a mistake. So just remember though, the x-axis here is going by ones. So I'm going to count right now by ones. This is 1 and this is 2. So I'm going to put a 2 on the outside. And then my rise, just be careful here, this is the rise. And you notice that the y goes up by 4s? These are 4s plus 4. So that means it's a 4. It's not a 1. It looks like a 1, but it's not. So rise over run is 4 over 2, and m equals 2. This is a positive slope. It goes up from left to right. We're good to go. So number 4 says, what does the rate of change show? Just remember, you had $4, right? It's $4 on the y-axis, and 2 minutes on the x-axis. So this is 2 minutes. So it's dollars over minutes. So what does the rate of change show? It shows how much money it costs per minute. And there it is, how much the phone card costs per minute. I just put the symbols of what each number represents right next to the numbers, and you could just kind of see exactly what the rate of change shows. All right, the card has a purchase fee, and I just want you to remember this purchase fee right here. If I could get the highlighter to work, that purchase fee is the y-intercept. So just remember, the purchase fee is the y-intercept. It is the initial value. So if this is the initial value of the card, initially when you go in to buy a phone card, you're going to be charged before you even use 1 minute. So right here, 0 minutes, they were charged $4. So it's charged $4 for 0 minutes. And it's shown as the y-intercept and initial value, right? That's what it is. It's initially, what do you have to pay before you start using the card at all? And that's it. So there's a lot of questions here, and these are very, very good questions to get things straight and make sure that you understand everything about all of this, right? So explain your answers in your own words. How can you recognize a linear equation? If it's in y equals mx plus b format, it is a linear equation. Linear. Linear means line. So if this right here confuses you, it has the word line in it, and line means linear, straight. So if you're going to answer the second question, how can you draw its graph? The graph of a linear equation is straight. If that line is straight, it is linear. If the line is straight, it's linear. Right? Write an equation that is linear. Anything in y equals mx plus b is linear. So you could say y equals 4x plus 10, or y equals negative 3x minus 12. Right? Any of those two, or anything in y equals mx plus b form, or even anything that looks like a little bit strange. So if you have y equals x over 3 plus 2, Well, that's 1 over 3x. That's what this is. This is the slope. This is 1 over 3x. So you could have y equals 1/2 x as a direct variation. As long as it's in y equals mx plus b, it is linear, straight. So anything that is not y equals mx plus b is non-linear. So we're going to start off with y equals x squared. Y equals x squared, you take a look at the graphing calculator. If you press y equals, we'll get that out of there, because that is linear. X squared, and we press graph. You could see right now that that is a U shape, and a U shape is nonlinear. The next equation that I want to bring or call your attention to is y equals 3 over x. Y equals 3 over x is non-linear. If you look at y equals and you graph it, you could press alpha x and you could put 3 over x and you press graph, and you could see that that right there is slowly non-linear. If you have an equation that is equal to y and it's y equals 2 to the x power when the x is the exponent itself, you can also say that that is non-linear. Y 2 to the x, let's go ahead and 2, and that caret button is to the for the exponent, and we are pressing right there, and again non-linear. Another equation that is nonlinear, and we have absolute value of x, and is not y equals mx plus b. We could bring up the calculator. To get to the absolute value in the calculator, you have to press math and go over to num. You see that absolute value there. You press 1, and there it is. Brings you back to the graphing page, the y equals, and you see what that is. That is a V shape. In the shape of a V, that is also nonlinear. There's a lot of others that are nonlinear, but those are just a few of what they are. All right, not y equals mx plus b format. Write a linear equation that is parallel to y equals 3x minus 4. Y equals 3x minus 4. Remember, it has to have the same slope. If it has the same slope, must have the same slope with a different y-intercept. If it has a different y-intercept, remember, then you're talking about a parallel line, a different y-intercept with the same slope, then you're talking about a parallel line. So anything with this one, y equals 3x minus 4, anything that has a 3x in it will be parallel, right? So you could put y equals 3x, and simply put, that has a y-intercept of 0. This one has a y-intercept of negative 4. Y equals 3x plus 2. Or y equals 3x minus 2. Right? As long as it has the same slope with a different y-intercept, it is parallel. So we're talking about John's savings account here. We're going to investigate the initial value. Remember we said the initial value is where the line starts. All right. So if we have something start right here, that is the y-intercept. That is the starting point. That is the initial value. So the B equals 300. The initial value is the B, and you just put that down. What is the rate of change? We are going to take our pen and we're going to draw a rate of change. You could even go right here. That's a nice point. Let me just go ahead and draw that small little triangle right here and here. So that is 1. So the run is 1, and the rise, be careful, is 100. It's going up by hundredths. So we have an m of 100 over 1, and that m equals 100. Write the equation of this line. Well, it starts at 3. The b equals 300. The m is 100, so it's y equals 100x plus 300. Use the rate of change to calculate how much John will have in his account in 15 months. So, very easily, you can extend the graph, or you could use the rate of change, or you could use the equation where you have 100, and instead of x, we're going to substitute the x in at 15 months, because the x is represented by months. The months are represented by the x. So we're just going to put 15 in, plus 300. I'm going to go to the calculator and do 100 times 15 plus 300. And that's exactly what I have on the page. It's $1,800. So y equals $1,800. That's how much he will have in 15 months. You could also extend the graph. All right, so this would be 13, this is 14, this is 15. So we're just going to go and continue the graph up like this. And here's 15. So if I continue the graph up like this, look, 1,800. The problem is when they ask you for a number off the graph, again, you have to use that equation, and I think it's the easiest way is to actually substitute for the x and then get the y in return. All right. All right, so here we go. I'm going to get a highlighter out for this, and you have $100 in your savings account and plan to deposit $15 each month. So we have months here, so time always goes on the x-axis. Time always goes on the x. I'm going to start with 0 and just number my months by ones. Just like that. That 10 has to be moved over just a little bit. Let me erase it because it just doesn't look all right. Remember, you're numbering the lines itself. Right underneath the line, that's where your number should be. And it goes all the way to 15. So if this person starts with $100 in the savings account, that's what you start with on the y-axis. So what the person starts with is 100. So the b equals 100. The slope, the m, is how much that person is depositing each month. So if this is going by months, if the x is going by months, after the first month, he starts with $100, and after the first month, he's going to add $15 to the 100. So that means he's going to have 115. So you're increasing your graph, your y-axis, by the 15, 15, 15, because the person is adding $15 per month to the account. So this is 130, this is 145. You're counting by 15s. 175, 190, 205, 220, 235, 250, 265, 280, 295, and 310. All right, so that's $15. That's where I got that from. But there's one thing that I forgot to do. And I have to add something right here. You can't just go up to 100, start at 100, and then go up by 15s. Now, you could start at 100 and keep on going by 100, but you can't start with 100 and then increase by a different amount. So we have to add something called a break. That is definitely needed, and the break will skip to 100 and then allows you to increase by a different amount. All right, write and graph the linear equation that represents the balance in your account. Again, we started with 100. We're adding 15 over 1. So the B is 100. So we're starting here. I'm going to just put a nice big point right there. And then it's a rise of 15, a run of 1. And since you increased by 15s already, this is all your graph looks like. It's an increase of 15, rise of 15, a run of 1. And you set yourself up to have a nice, easy graph. Connect those points, go extend all the way across and off the graph. Make an arrow, and we could see that the equation is going to be y equals 15x plus 100. Y equals 15x plus 100. And that is it. So how many months will it take you to save $205? Well, the 205 is right here. So I'm going to go across and hit that and go down, and it will take you 7 months. And that's using the graph. If you wanted to use the equation, then how many months would it take you? You have to solve for x. So 205 is the y, because that's the money, equals 15 and then x plus 100. Subtract 100 from each side. And you're solving for x. This cancels. This is 105 equals 15x. And then you divide by 15. This cancels. And you get x equals 7. So it's the same if you use the equation or you use the graph itself. And that is that. To go to the next question, we are going to look at what is, or investigate, the function modeling this rate of fuel leakage. And you could see that it starts at 18 gallons and goes down all the way to 0 gallons. All right, so the initial value is this part right here, where it actually starts. The initial value is 18 gallons. So I'm going to put 18 gallons. The rate of change, I'm going to go and actually, I'm not going to use that other point. I'm just going to go and use this point right here. because that's a perfect point. You see how perfect that is? They're all perfect points. So you could go down and use it. I just don't want to. It goes from 18 to 16, so that's a -2. And then the run is 1. So the rate of change is -2 over 1. And then I'm going to put the words in to make sense of it. -2 gallons per minute. So the rate of change is -2. -2 over 1. So you could put m equals -2. So y equals -2x plus 18. That's y equals mx plus b. This is a negative slope. It goes down from left to right. What if the tank were leaking at 3 gallons per minute? Describe how the graph would change. So this is 2 gallons per minute. So now we're going to have 3 gallons per minute. And I'm just going to erase some of this right here. And this is 2 gallons per minute. But now I'm going to go down 3 instead of 2 and then over 1. So if I have a rate of 3 gallons a minute, it would be down 3 and right 1. And I'm going to change that to a different color. Maybe. Down 3 and right 1. I'm not going to change it to a different color. Okay. Down 3 from, this is 15, 14, 12, and 1. So down 3 to 9 and 1. Run. Down 3 from 9 to 6 and a run of 1. Down 3 from 6 to 3 and a run of 1. Down 3 to 0 and a run of 1. So you can see that this line right here, now that we're going to pick a different color here to represent that line. So take a look at that line. So if the tank were leaking at 3 gallons per minute instead of 2, describe how the graph would change. Well, the line would be steeper. The slope of that line is steeper because it's furthest away from 0. -3 is further away from 0 than -2, so that line is steeper than the original line. It also will run out of fuel in 6 minutes versus 9. All right, those are the differences. And that's what I wrote down right there. If the tank leaks at 3 gallons per minute, like you see on the black line, the line would be steeper because the rate is further from 0. The tank would run out of fuel in 6 minutes instead of 9. And that is it, right? So if you were labeling these lines, you would have this one here as y equals -2x plus 18. And this one here as y equals -3x plus 18, plus the same 18. Because you're starting with 18 gallons of fuel. Okay, so it says try this. Do the points 2, -2, -1, B, 1, 5, and C, 4, 11 lie on the same line. Without a graph, how can you justify your answer? With a graph, you would just try to graph these and see if they are on the same line. Because remember, a line has a constant slope. But without a graph, I'm just going to use the slope formula also. Like, I'm not using the formula, but I'm going to use patterns. So I'm just going to go and put the -2 right here, comma, -1. And I'm going to spread it out. This is A. This is B, 1, 5, and this is C, 4, 11. And I'm just going to take the X values, and I'm going to see what's happening with the X's. So just take a look. From -2 to 1, that's plus 3. From 1 to 4, that's plus 3. So it looks good. So it says it's adding 3 to each X. All right, let's go ahead and talk about the Y though. What's happening from -1 to 5? That's plus 6. And then 5 to 11 is plus 6. So yes, they do keep the same slope, the same rate. So that means they are on the same line. And there it is. The points lie on the same line because the X and Y coordinates increase at the same rate. And by the way, they could decrease too, but it just has to be the same rate. The same rate. Okay, the graph shows the amount of money in Will's savings account every week, each week. So we're going to talk about the rate of change and initial value. So right here is the initial value. I'm going to say that is $25. It's in between the 20 and the 30, so I'm guessing it looks like it's 25. The rate of change, I'm going to put this point down, and then I'm going to look for another perfect point, which is this one. Then I'm going to do rise over run. So we are going to talk about 1, 2, and then 10, 20, 30. All right, remember they're going by tens. Okay, so the rate of change is 30 over 2, and you could see going up, you're increasing, the Y is increasing by tens, so just be careful. It looks like 3, but it's not. It's 30 over 2, and 30 over 2 equals 15. All right, the rate of change is $15 per week. And you could see it right here. And I'm just using the words that are on the graph. So we have $15 per week. Y equals 15x plus 25 is the initial value. Describe why the graph does not begin at 0, 0. It's just because Will had $25 in the savings account to begin. Basically, Will had $25. I think I said 15. Will had $25 in his savings account initially, and that's why it does not begin with 0, 0. If it did begin with 0, 0, it would, obviously he would have nothing in the account at 0 weeks. All right, so here we go with Sal, and Sal earns $15 per hour selling books. So again, remember the x-axis is time. So we're just going to go 0, 1, 2, 3 and count by ones. And it goes up to 15. Now, talking about the y-axis, we're talking about money. So we're talking about money on the x-axis. Sal makes $15 per hour, so we are just going to count by 15s. And just like that, we're going to be up to 135, 150, 165, 180. Counting by 15s, 195, 210, and then 225. So if he earns $15, and we don't need a break because, again, we did skip from 0 to 15, but now we continued by 15s, so then you don't need a break. As long as you continue with the same, by the same number, all the way up, then you're good to go. All right, so again, he makes $0 for 0 hours. He makes 15 hours, $15 per hour. And this is it. It's a rise of 15, a run of 1. A rise of 15, a run of 1. And it goes up the graph just like this. This is a direct variation. because he makes $0 at 0 hours. You connect those points. They are very straight. This is a constant rate. I'm just moving this over. And I'm going to put an arrow on the end and put y equals 15x, and that is the equation. The rate of change is 15 over 1, which is m equals 15. The initial value is 0. And it says graph the function, and we did. That is the graph. For the next one, again, a phone salesperson earns $12,000 per year plus $500 per phone sold. Right? What's the rate of change? The rate of change is the M. It is $500 per phone. The initial value is $12,000. That's initially what this person gets paid. Use the rate of change in initial values to write the function. The function is the y equals mx plus b. It is y equals 500x plus 12,000. And that is it. All right, we are going to graph that. Just split the screen. And remember, we're talking about per year. So that means the years, since that's time, it's going to go on the bottom. And we're going to just count by ones, just like this. And that will go all the way up to 15. Now, $12,000 per year, we're going to have a break here. And we're going to start with $12,000. That's $12,000 because that's what he earns if he sells absolutely nothing. Just nothing. So we're going to put that $12,000 right there in that first line. Now, how much does this person earn? Sells one phone. 2 phones. Well, the increase is 12,500. And we're going to go up by 500. This is 13,000. This is 13,500. 14,000. And we just kind of increased by 500ths all the way up. All right, so we have the years down on the bottom. So we're ready to graph. He makes, this person, salesperson, makes $12,000 for the year. But the thing is, he doesn't have to sell any phones. So the salesperson is not selling any phones. At 0 year, I'm just going to make a change here. This is not year. And it's phones. All right. So it's not time in this case. It's phones sold. So for 0 phones that the salesperson sells, still making $12,000, which is awesome. 1 phone increases the pay by 500. 2 phones increases the pay by 500. You just go up like this. Make a nice big point, and you go up just like that. And that is it. Connect those points. And you put an arrow right there. And we had the equation is y equals 500x plus 12,000. And that is it. Okay, it says write an equation that to help represent the situation, use the rate of change. And here we go. So I'm looking at this right here, and computer repair person's rate per hour in dollars, 0.75. I'm going to list this as X1 and Y1 because the one thing that I do need is the slope, X2 and Y2. But the rate of change is different than the initial value. The initial value, remember when the X is 0, the other number is the B, and the y-intercept is 75. That is the initial value. The rate of change, we are going to do m equals y2 minus y1 over x2 minus x1. And we're going to just put down m equals minus minus, and then we're going to do, let me move this over, just like that. Y2 is 125. Y1 is 75. X2 is 1. X1 is 0. So I'm going to do alpha x. I'm going to put this directly into the calculator. 125 on the top minus 75 as the numerator. And then on the denominator, it's just simply 1 minus 0. You press enter. The calculator gives you 50. That is your answer, 50. So it's $50. So the linear function, the equation is $50, 50x plus 75. And that is it. State a reason why the first value is 75. That is the initial value that this computer repair person is charging. That is the initial value. So before the computer repair person even starts to work, any hours, they're charging $75. And that is that for that one. Okay, write a same thing, write an equation to represent this situation. Table of values shows the volume of water in a reservoir every 2 hours. So we are going to go down right here and just put X1. And this is Y1. This is X2. This is Y2. So the rate of change we're going to figure out as M equals Y2 minus Y1 over X2 minus X1. We're going to put down M equals, and I'm going to go 180 minus 240, and then 6 minus 4. And we're going to put M equals, and we'll see what that basically what we get in our calculator here. 180 minus 240, 6 minus 4. No, not 5. Delete that. 4. Enter. Negative 30. So it's losing 30 gallons. The time says like hours. So per hour. Negative 30 gallons per hour. All right. The initial value is a little tricky. You need an X of 0. So you could do this, but the thing is, might involve like a point slope formula because you have the slope and a point. I don't want to do that. I just want to see if I could do this by, with the patterns that are here. So I know that 240 to 180 is minus 60. And if I go up though, that's plus 60. So if I go up here, plus 60, that's 300. Right? So the X though is increasing by 2, but if it goes this way, it decreases by 2. So if I'm going and if I'm decreasing by 2, this is 2 now, right? Minus 4 minus 2 is 2. And then if I decrease by 2 one more time, there's my 0. I need my 0. So this 300 now, if I increase it by another 60, I'm sorry, this 300, and increase it by 60, that is 360. So what is let me just erase that and put it nice and big where we have 360. So the initial value is 360 gallons. I needed to get the x of 0. Once the x is 0, that means you have a y-intercept of 360, and then you're good to go. All right. If the x isn't 0, like down here, a lot of people are saying, okay, the 12,0, that's the y-intercept. No, that's the x-intercept. The x has to be 0 for the other number to be the y-intercept. So we have a rate of change of negative 30 x plus 360. And that's basically how I would say it. The water in the reservoir is decreasing 30 gallons every hour. Okay, we are going to skip the baseball, and we're going to go right to the exit slip. We're taking a look at what Tara creates a budget for our weekly expenses. The graph shows how much money is in the account at different times. The slope of the line, we know that the slope is negative, right? Because this goes down from left to right. And they do have all slopes as negative except for D, so I'm going to cancel that out. All right, the slope is negative 50 and negative 50. It's negative 0.02. So I'm just going to list this as x1 and y1 since there are no lines here, x2 and y2. So I'm just going to go m equals y2 minus y1, and we're going to have 2,000 and then minus 2,400. We know it's a negative because it goes down from left to right, 12 minus 4. So I'm going to just go ahead and take my calculator, clear it out, and make sure that I'm putting the right numbers in. 2,000 minus 2,400. So 2,000 minus 2,400. And then over, and let me just go down again, 12 minus 4. So I just want to make sure that I'm substituting the right numbers into the calculator, and it's negative 50. So that means this is out, no matter what is going on. So m equals negative 50. And let's just read it now because both of them say negative 50. The slope means that the amount of money of the account is decreasing at $50 every week. That's 1. Remember, a slope is always to a unit of 1. And the slope of negative 50 means the amount is decreasing at a rate of 50 every 2 weeks. We are not talking about 2 weeks. Remember, rate is every 1 week. It's to a unit of 1. So A is your answer, and that is it. All right, that is your exit slip. Right. Just to go back to the card thing, just really quickly, any cards that are decreasing in value have a negative slope. So card A, decreasing in value. Card B is increasing. Card C is increasing. Card D is decreasing, negative slope, and that's basically it. Which cards have the greatest initial values at purchase? This has 5, this has 4, this has 10, this has 10, and this has 8. So which cards? So the card C and card D. And they have a B of 10. Okay, which cards is increasing in value the fastest from year to year? So this one's decreasing, so that's out. This one's increasing 2.6, furthest away from 0. 0.9, no. Negative, no. This one. So card B the M, you could tell by the M being the furthest away from 0 is 2.6. If you were to graph the equations of the resale values of card B and card C, which card's graph line would be steeper? So card B has an M of 2.6. Card C has an M of 0.9. So let me get this. So which one would be steeper? Obviously B would be steeper. And B would be steeper because, again, because the slope is further from 0. And that's basically it for that one. There's just looking at the slopes and telling whether or not the card is losing value or gaining value. Anything with a negative slope that's losing value. Anything with a positive slope is gaining value. Anything that's further away from 0, that is the greatest slope, the greatest rate of change. All right, that's it. This is the exit slip. A is your answer. And I hope that video helped. Thank you for watching.